Two cars start moving from the same point. One travels south at 60 miles per hour and the other travels west at 25 miles per hour. At what rate is the distance between the cars increasing after 2 hours? The first thing we need to do is figure out which method we will use to solve an exercise like this, to answer this question. What I see is that we have a car traveling at 60 miles per hour, and we have another car traveling at 25 miles per hour. These are both units per time measurements. These are both rates. These tell me that this will be a related rates problem. So we will need to use implicit differentiation with respect to t. Let's write down what we know. We know that starting from a point, we have one car that travels south at 60 miles per hour. The other car travels west at 25 miles per hour. The question is, at what rate is the distance between the cars increasing after 2 hours? Well, the distance between the cars is this distance here. So it looks like we're trying to relate three sides of a triangle. Since one car is traveling west and one car is traveling south, that creates a 90-degree angle, which allows us to use Pythagorean's theorem. We'll call this side A, this side B, and this side C. So the distance between the cars we will denote with the variable C. This allows us to use the equation a squared plus b squared equals c squared. And we can take the derivative of this with respect to t just by performing the power rule on all three variables. So the derivative of a squared is 2a, the derivative of b squared is 2b, and the derivative of c squared is 2c. But every time we take the derivative with respect to t, we need to put the rate behind these derivatives. Let's write down what we know. We know that the rate at which this distance a is increasing is 60 miles per hour. So dA dt is 60. We know the rate at which this distance is increasing is 25 miles per hour. So let's call that dB dt, the rate at which b is changing. And we're trying to find the distance between the cars, how fast that rate is increasing. So we are trying to find dC dt. And as it stands, we know two rates, and we're trying to find the other rate. But over here in our equation, we have many more variables than just these rates. We don't know A, we don't know B, and we don't know C. But we can find these values out by using these rates given to us in the original exercise. If a car is traveling 60 miles per hour and the car is driving for 2 hours, we know that this distance A is 120 miles. Similarly, we know that this car B, is traveling at 25 miles per hour for 2 hours, so we know B is 50 miles. And in order to find c, we don't know anything about the distance between these two, but we know the Pythagorean theorem and we can figure out the distance between these two cars after 2 hours by using a as 120 and b as 50. And when you use Pythagorean theorem to figure that out, you get that the cars are 130 miles apart from one another. From the previous slide, we have the derivative and all of our information. So all we have to do is substitute this information in and solve for dc dt. So here we will have 2 times 120 times 60 plus 2 times 50 times 25 equals 2 times 130 dc dt. When you simplify the entire left side down, you get 16,900, and for the right side, when you multiply 2 times 130, you get 260 dc dt. And when you solve for dc dt by dividing by 260, you get dc dt is 65 miles per hour. That is the rate at which the distance between the cars is increasing.